Yo, what's going on, Pre-Algebra? It's Mr. Lopez, and today we're going to talk about surface area, specifically surface area of prisms and cylinders. Prisms and cylinders. If you remember from previous lessons, we have talked about prisms and cylinders before. Right here is an example of something that is called a prism, and over here is an example of something called a cylinder. All right, if you guys remember, prisms and cylinders had one thing in common, that they both had two bases. All right, bases, and prisms have two cylinders, or two bases. Prisms have two bases, and cylinders have two bases as well. Now, we're going to be talking about surface area today. Surface area today. Usually when we think about the word surface, we usually think about like the outside of something. And area usually has to talk about a certain amount of space. So for surface area, we're going to combine these two things together. We're going to talk about the space around the outside of a figure. Like in this example for this prism, like this example of a Kleenex box. All right. What would constitute the surface area? Well, the surface area would include the top of the Kleenex box, the bottom of the Kleenex box, and also the sides. So if I think about the top of this box and the bottom of the box and the outsides of the box, that would give us everything, all the area of the surface. All right, and because there's two bases, the top and the bottom would be considered the bases. All right, now we can apply the same exact definitions for surface area, the same exact components of surface area for the cylinder here. Every cylinder, like this Clorox wipes box, which or little container, which is probably very prevalent in your lives right now. We would probably, if we want to talk about the surface area, we would talk about the top, the bottom, down here, and everything around the sides. All right, so today we're going to be talking about surface area, and that's what we want to keep in mind. We want to keep in mind the top, the bottom, and the sides. All right, all three of these things would give us our surface area. Now, going back to our textbook, they kind of give you a few more definitions. They say for prisms and cylinders, they can be either right or oblique. Right prisms and right cylinders are perpendicular to their base. So in this case, the base on the bottom is going to have a perpendicular line going straight up and down for the right prism and the right cylinder. Where oblique is just a fancy way of saying slanted, where this oblique prism is still kind of slanted, it's kind of pushed over. And the same thing goes for this oblique cylinder, it's just kind of slanted and pushed over. Now notice the height is going to be really important for us to figure out. The height is going to be the distance from the base to the top, or from the floor to the ceiling. So in this case, this would be the height. And the same thing goes for obliques. For obliques, it's going to be the height from the floor to the ceiling. The slant height, as it is called, does not matter for this type of shape. All right, so for prisms and cylinders, the height is going to be from the floor to the ceiling. Make sure you have that written down in your notes. Height is from the floor to the ceiling, from the bottom to the top. The surface area is the sum of the areas of the bases and the lateral face of the space figure. Basically what they're saying is that it is going to be the combination of the two bases and the sides. Now, in a previous lesson, we've talked about how to draw net diagrams, or just nets of space figures like this. And what we could do is, if we picture this as a box, and if we cut the box up and we kind of laid out all the different pieces, it would make all these different little rectangles. So one way that we can find the surface area is if they give us the net diagram, just to find the areas of each individual rectangle and add them together. So if this has a base of 5 times 8, the area is 40 inches squared. This side is also 40 inches squared. This has a base of 20 times 8 inches tall. 8 inches tall is 160, and the other areas are just kind of added together. So the surface area for this entire figure is going to be 600 square inches. Why? Because area is square area. So these ones are kind of nice and easy. If they give you a net diagram, all you have to do is find the areas of each individual little section and then add them together. So here is standards check number 1, where they give you a diagram that says find the surface area of this triangular prism. Now for the homework, they do give you 2 problems that do give you the surface or the net diagram. But this one they didn't give us, so I went ahead and drew it out for you guys. Notice that the first thing I did with this one is I noticed that it had 2 triangular bases. This is a triangular base right here, and this is a triangular base right there. So I went ahead and have my triangular bases over here. Then I have the rectangles that are connected. It's kind of hard to see which side goes with which, so I kind of color-coded them for you, just kind of paying attention to what's going on here. Now notice this has a right angle right there, so there should be a right angle here, which it has. On the right angle, this long side is going to be 4, and this side is also going to be 4 yards. And I color-coded. If I try to fold this figure up, this black side right here is going to connect with this black side right here. So both of these actually have lengths of 4 yards. This height right here is 3 yards. 3 yards, so this would be 3, and this would be 3. This slanted section right here is going to be 5 yards, and if I folded it, it would connect with this. So these guys go together. It looks like the top across is 6, and this is 6. With all this information, we can find the areas of each individual rectangle or triangle. Like in this case, 4 times 6 would have the base times height would be 24 yards squared. This section would be 6 times 3, which would be 18 yards squared. I should have done this in a different color. All right, this is going to be 6 times 5, which would be 30 yards squared on the inside of this guy right there. 24, 30, cool. Now we need to find the area of these triangles. Now the good news is that these 2 triangles, because they are part of a prism, they are congruent. They're the same size. So if I find the size of one, I find the size of the other. If you remember, the formula for the area of a triangle is base times height divided by 2. The base was 4, the height was 3 divided by 2, cross cancel, and I end up getting 6. This is going to have an area of 6 yards squared, and this guy is also 6 yards squared because they are congruent. The total surface area for this would be 30 yards squared plus 18 yards squared plus 24 yards squared plus 6 plus 6. If I add all of these together, 10, 18, 24, 5, 6, 7, 8, 9, 10. So this is going to have a total area of 104 yards squared because area is square area. Now this is just one way to do this. Again, this one requires you to draw out the net diagram and find the individual areas of each section. Luckily for us, everything was either a rectangle or a triangle, which are fairly easy shapes to find the area for and things we have to kind of get used to. But there's got to be a better way. There's got to be a different way to solve these. Well, let's go ahead and see what example 2 has in store for us. A different way, a more formulaic way of finding surface area is by finding something called the lateral area. Lateral means side. So if we wanted to find the area of just the side of a prism, or I guess even a cylinder, all right, we would need to be able to find the perimeter times the height. Now here, if I had this box and I kind of unraveled the sides alone, it would just be the perimeter of the base times the height of the prism. Perimeter times height. That would be half of it. But remember, surface area has two bases, a top and a bottom. So we could say that the surface area of a prism is going to be the lateral area plus 2 times the area of the base. If a shape has two different bases, like let's say the Kleenex box, then we will want to find the area of one base and multiply it by 2. So basically, all we're doing is finding the perimeter times the height, the perimeter of the base, times the height of the shape, and we're going to add the two bases together. For example 2, they ask us to find the surface area of the triangular prism at the right. So this is the formula we just kind of talked about. The surface area is equal to the lateral area plus 2 times the area of the base. But another way we can write this is the perimeter of the base times the height of the prism plus 2 times the area of the base. Over here, we're going to go ahead and figure out all this information that we need in order to solve our problem. First, we want to find the perimeter of the base. The bases in this case are triangles. It's a terrible triangle. Boom, boom, boom. We want to find the perimeter, the added distance. It looks like this side is 5 centimeters, this is 6 centimeters, and this is 5 centimeters. So 5 plus 6 plus 5 is going to be 16 centimeters. This guy right here is going to be the height at 12 centimeters. I know this is the height because the two bases are the triangles, and if I flip this over instead of right side up, this would be the height. The area of the base for this triangle is going to be the base, which is 6 centimeters, and the total height of the triangle is 4 centimeters. So it looks like this is going to be 12 centimeters squared. That means the surface area is going to be the perimeter, which is 16, times the height, which is 12, plus 2 times 12. All right, so because we are in chapter 10, we can use calculators. I can just go ahead and multiply 16 times 12, 16 times 12, which is 192. 192 plus 2 times 12 is 24. 192 plus 24 is 216 centimeters squared, because we're talking about surface area, and area is square area. If you need to pause the screen just to kind of copy this information into your notes, I understand. But here is all the work for standards check number 2. They asked to find the surface area of the prism at the right. I noticed that this prism is a rectangular prism instead of a triangular prism, so that's nice and easy for us. I found the important information. The perimeter is going to be 3 plus 4 plus 3 plus 4, just to add a distance around the base, and I got 14. All right, I also have the height is 6 meters. The area of the base is just going to be 3 times 12 because this is a basic rectangle. I plug in all of my information in. 14 times 6 is 84. 2 times 12 is 24. I add all these together, and what do I get? 108 square meters, because we're talking about surface area, and area is square area. So if you need to pause the screen to copy this down, I understand. The last thing for us to talk about is finding the surface area of cylinders, and guess what? It works the same exact way. In order to find the surface area of a cylinder, we need the lateral area times 2 times the base. Because the cylinders have circular bases, we're just going to go ahead and use our circle formula. And it's actually probably a little bit easier. It's going to kind of simplify into this formula. Surface area of a cylinder is equal to 2 pi RH plus 2 pi r squared. Now notice, the only things that we need in order to solve this problem are the height and the radius. Everything else is a given information, and this is where all this stuff comes from. I plug in my values for my radius and height, and I go ahead and plug in around to my nearest centimeter, and I get 330 square centimeters. I know it's a lot, but I know you can do it. Go.